What's good, guys? In this video, we are gonna have an introduction to the Dart programming language for beginners. And so if you are new to programming, or you may have a little bit of experience and you're just new to the Dart programming language, this is gonna be the video for you, because in this video, we're gonna be covering everything that you need to know to get started with Dart, all the features, all the functionality, and really the main purpose of this video is to get you to be more comfortable with Dart so that you can begin writing code and graduate from kind of beginner apps, intermediate apps, to maybe to some more advanced apps down the road. Now, before we begin talking about how to program in Dart and how to write apps in Dart, let's first talk about setting up our development environment regarding what kind of language you're going to be building code in, whether it's Dart or any other language. You need a development environment. A development environment is an environment where you can write code and it can format the code. It can tell you if there are any bugs in the code. It can also help you with some of the other things, maybe some syntax highlighting. And ultimately, it's a place where you can run the code. So one option for a really good development environment is an app called Visual Studio Code, and you can download this for your machine, regardless if you're using Windows, you're using Mac, you're using anything else. You can simply download it. So they support Mac, Windows, or Linux here, so you can download it. This is my main editor of choice. This is the app that I use for all of my projects, regardless whether it's Dart, Flutter, Python, or pretty much anything else. And so I have it here loaded, and on the left-hand side, there's an Explorer. There's also Search, Source Control, and what's nice about this specific editor is it has support for extensions. So I have a Dart extension. I also have a bunch of other extensions. And this Dart extension helps with code formatting, and it just makes it a lot easier and a lot more pleasurable to work with this language. Obviously, you can edit your code in a very simple editor like TextEdit, but it's a lot better to do it in a more kind of suitable environment. So I definitely recommend Visual Code Studio. Another option, and that is an option that if you want to use the web and you don't want all the bells and whistles, you just want something quick and easy to test an app, to test a function, you can use a Dart pad. And if you head over to dartpad.dev, you're going to be looking at a screen such as this one. And here you can write your code. You have a console, which is where the code gets outputted. You have some documentation there as well. And this is really nice for testing a very small function, seeing if it's going to behave the way you want it. And really, you can even share it with others, right? You can format, you can do a lot of interesting things. And you can also send this link to other people so they can look at your code. Or if somebody asks you how do you build something, you can do it and send them a link. So this is nice to test something real quick. But for big projects, I use exclusively Visual Studio Code because it has a lot of these features, a lot of functionality that makes it a lot easier to kind of build a big app and have multiple files and all of that. And this is all stuff we're going to talk a little bit later in the video. Now, for today's video, we're going to be using exclusively Dartpad because it's a lot easier. It's a lot more lightweight for demonstrating quick and easy apps. And so let's begin. Let's get started. But before we begin with Dart, I want to talk to you guys a little bit about programming. What exactly is programming? Okay, how does programming works? I think we all have a general sense, a general idea what programming is, right? You're writing apps, you're building code, you're trying to get the computer to do something. But a really easy way to kind of define programming is that you are manipulating memory. Okay, so a computer has memory, and you're putting stuff into that memory. You're saying, well, this memory should be somebody's name. Take somebody's name and put it into this memory. and then, hold some other variable that's important to you and to your app in this memory, and then do something with it, maybe print it, maybe do something else with it. That's really the idea. It's a very simple concept, but it's all about manipulating data or manipulating memory, how you want to think about it. And that's really what programming languages do. They help you manipulate the data that's important to you. So you define the data, you assign it to some values that are important to you, and then you're manipulating it. Okay? So with that being said, hopefully that made some sense in a very kind of general, abstract way. With that being said, let's start building simple apps. So let's say we want to build a simple app, and let's say one of the typical examples when it comes to computer science is you want to build an app that prints hello world. Okay, and so how would you do that with Dart? Well, first you need to define your main function. Okay, and this is going to be a function where once your program runs, this is going to be the entry point, meaning that this is always going to be the first thing that runs, and from there on, you might run other things, but this is the entry point, and that function is called main. Okay, so if I define a function called main, I can put code inside, and that code will get always executed first. Okay, this is kind of how you want to start apps. Now, we're not going to discuss functions just yet. I'm going to get to it a little bit later in the video, and don't worry, there's going to be a chance to learn all that. But right now I want to talk about how to do something very, very simple. So once we have this function, we can do something like hello world. Okay, something like this, semicolon. And now you have a function, main, which is a unique function. It's not a function. It's not a user-defined function. It's a unique function that, because this is the function where everything starts, we have hello world. Now, as you can see, we don't have any errors. If I remove this, I'm going to have an error. You see this little underline? That means there's an error, and I have this error, expected to find semicolon. And this is automatically being checked for compile time errors. Okay, so it's important to kind of understand that. I know I'm a little bit running ahead, is that there's something called a compile error, and there's something called a runtime error. A compile error is an error that's immediately visible even before we run the app. So maybe you have something like this. Okay, that's a compile error, because even before we compile this app and turn it into something that the machine can understand, it's already visible. We already understand that, okay, we need to fix it. Okay, and the nice thing about these kinds of errors is that you can fix them before you run the app. The runtime error is an error that happens during the time your app is running and cannot be detected. Okay, so it's important to understand. So this is actually a good thing. It's telling us that we have an error. So if I go back to hello world and I don't have a semicolon, it's going to give me an error. And that's actually a great thing, because I can fix it right here, right now. And that means that, that error is fixed. And it's a lot easier to fix these errors than errors that are happening during runtime. So I just kind of wanted to include that real quick. Now, if I put a semicolon, we should have no errors. And so let's say I press run, I should see hello world on the console. This print is another function, and it's a built-in function, right? We're not defining this function. We're not doing anything with this function. It's a built-in function provided by the Dart SDK, right? The Dart software development kit. And there are lots of other functions that we're going to get to, but it's important to understand that this main is not a built-in function, but it's a function that we define. This print is a built-in function. Okay, so we're not defining this function. Okay, so now we have hello world. Another thing that you can do is, well, for the most part, when you're building apps, is that you're going to have variables and you're going to have functions, meaning that you're going to have some variables that hold values, right? And then you're going to have functions that kind of work on those variables. They might manipulate it, they might print it, they might do something with those variables. So as an example, let's say I do int a equals 10. Okay, and what I just defined is a variable called a with a value of 10, and the type is integer. Now, it's important to understand that a variable and a value are two different things, right? A variable is a placeholder. It's something, it's like a box, right? Think of it as a box. And inside that box, we have 10. And we also tell Dart that this is an integer. And that way, if we do something like this, Dart should complain. It should tell us that, wait a second, you are giving this variable a string. This is no longer an integer. This is something else. That is not correct. And that is why we have an error here, right? It's telling us that there's a mismatch. So if you go back to, let's say, 5, now there's no issues. Well, we do have one info. This is not an error. This is kind of informational. It's something that's good to know, right? It's not an error. Our app is still going to run, but it's telling us that the value of the local variable is not used. So it's telling us, like, why do we have that there when we're not using it? And this is really nice because, you know, why did you define it? Maybe you forgot to use it. Maybe your program is going to crash. Maybe you forgot to write a piece of code that's important, that's dependent on this variable. If you're not using it, just remove it. And then when you do that, that's it. This issue goes away. So there's that. So if we go back to that, int a is 5, we're not using it. Well, we can do print a. Okay, and that's going to print that variable. So if we run it, run our Dart app, we're going to see the number 5 here being printed, because now instead of printing a literal, right? This is a literal, right? This hello world is a literal. It's what it is, right? It's not, we're not, you know, using a variable. We're not, you know, pulling a variable and printing its contents. We're just printing the literal, okay? This is called a string literal. But in this case, so we can print the string literal, or we can print the variable directly. And obviously, if we print something else, it's going to complain that we're not using the variable if we're not going to be using it. But in this case, we're printing the variable directly, and in this case, you know, everything is fine. There are no issues. Everything is good to go. Now, int is just one of many types. Okay, so it's important to understand is that, you know, a computer, it stores everything in memory. So when this program runs, it allocates a piece of memory that it stores these variables. And integer is just one of different things, right? You can't build apps that only have integers. Another type of variable is a string. So I can do string name equals James. So now we have another variable, okay? So now we have a variable called name. It contains James. We're still printing A, but it doesn't know what A is, so we need to change that to name, okay? So now everybody's happy. If we run it, we're gonna see James right here. And there we see James. This is string. We also have a double. So a double is like a number, but, you know, with a decimal. So like 5.5 instead of just 5. So I can do num equals 5.5, or this actually 5.5. I can't do that. I can't do that with an int, because an int is only going to be like a whole number. So in many cases, if you are, you know, if this was an int, then it would cast it, meaning that it might, you know, cast it to the nearest number. So you want to make sure you're doing it correctly. This is going to be a double, okay? And so now you can print this right here, and that should hopefully print 5.5. Let's do that. All right, there you see it, 5.5. Another variable that you're going to be using from time to time is Boolean, okay? It's bool, and you can assign it something like is happening, okay? And you can say true. And a bool contains either true or false, okay? So it's going to be either true or false. It's not a number, it's not a string, it's going to be either true or false. And so, you know, this means that you can use it with conditions. So right now it's true, so later on we can check, oh, is this condition true? Then do something. If that condition is not true, then do something else. It's very important when we're talking about computer science and computers that you have a true or false value, because a lot of things in computers, right, you're going to have conditions, you're going to have all this logic, right? Everything is logic, right? We're talking about manipulating the variables, and that logic will depend on the true or false value. And so even if you have like strings, you might be comparing them, you might be checking if they're true or not true. So this is important. Now you can have types that contain many variables. A very popular is a list, right? So you can have something like a list, and you can say my list, and you can say, well, This is a list of integers. And so now you can see that my list actually is not just one number or one string or one value. It's actually a collection of something. So instead of like a box, think of it as like a collection or like a big compartment that has many, many boxes. So in this case, we have list, my list, and then we have the integers. Now, if you want to make sure that this list, this specific my list can only have integers, that meaning that you want to force it just to be integers, you need to specify the kind of type it's going to be holding on to. So I'm just going to say int. This means that this list here can only be of integers. So if I have something like strings, right? So if I delete it and say hello, hey there, that should not work because I just said this is an int, right? So this is going to be an error, right? So it's telling me it's an error. But if I remove that, then it's going to figure out on its own that this is a list of strings, right? So you can force it to have a specific type, or you can have it infer the type, right? So you can do that with regular numbers or strings as well. So for instance, remember we did string name equals James, right? We're saying this is a string, but I can do var. That means that, well, you know, it could be anything. And that way, Dart is flexible enough to infer it. Now, if you know the type, if you know that James is only going to be a string, I highly recommend it to make sure that you specify the type, because that way you are forcing Dart to be strongly typed. And what that means is that you're telling Dart name can only be string. If it's assigned to somewhere else, maybe somewhere down there, tell me about it. Let me know, because that should never happen, right? So it's very, very important to understand that. So that is a very nice feature of Dart, is that you can force it to be a certain type, but you can also have it infer the type. And I would recommend, if you know the type, that you force it to be the certain type. So we talked about list. I can have a list of integers, 1, 2, 4, 5. Now it's a list. And well, let me specify the name of the list, my list here. And now we have my list, which is a list of integers. And what's nice about it is that you're going to be using this list all the time, right? Lots of situations, you need to store multiple things, maybe multiple numbers, multiple names. You can store multiple objects, which we're going to get to in a second. Lots and lots of things. So this is very, very important to understand. Another variable type that you can have is a set. So you can have a set, let's say, of integers, and you do that by doing it similarly how you had a list, except you're going to do the curly braces, 1, 2, 3, 4, something like this. And now you have a set. What is the difference between a set and a list? Well, a set only holds unique values. Okay, so a list can have any kind of values, but a set only holds unique values. So a really nice life hack, which you're going to learn a little bit later on, is that when you have a list and you only want the uniques, you convert it into a set and then you convert it back to a list. So that is a quick life hack that's used all the time everywhere. And so that right there is a set. Another very important data type you're going to be using from time to time is a map. So as an example, this right here defines a map. Gifts is a map, and a map, the way it differs from the other types is that it has a key and a value. Okay, so in this example, a list just has a list of items. Okay, it's just a list, it's an array, it's a list of computers, a list of cameras, a list of ages, a list of names, just a simple list. A set is a unique list, essentially. But sometimes there are situations where you need a little bit more data, right? A really good example is a map that has a key value, right? So now you have a value called gifts, and it has key value pairs. So meaning that you have first, second, fifth in this example, and then you're getting the value. And then later on, you can simply get the right object depending on the key. So with a list, you can't get a specific object that you want. You can get maybe like a fifth or a sixth object, but here you can get maybe the second or the fifth. So if I can, I can just print it like this. I can say gifts first, okay? And that's going to print part-rich, right? So if I run this, that should hopefully print part-rich right there, and we have part-rich. Now, the main difference between these types is that with a list, you can access an element by its index. So for instance, let's say I want the first element. Well, I can get it. I want the last element. I can get it. With this map here, I have more information. Not only can I access maybe the first or the last element, I can access an element by its key, right? So I have more information here. I have key value, I have pairs instead of here, which is just one item. So for instance, here, I can print my list first element. Now it's important to understand the counting in computer science starts from 0. It does not start from 1 as you would expect in, let's say, in our case, how humans count, right? We count from 1, but computers count from 0. So 0 would be this element right here. 1 would be this element. So if you have 5 elements, you're going to count when you're going to be programming from 0 to 4. So if I do, let's say, my list 0, it's going to print 1, which is the first element. So I can simply do that. Okay? And now it's printing the first element. And with this map here, I can do something else. I can say print gifts. And I can say, well, print me the value where the key is second, right? And which is going to be turtle doves. So if I print this, I'm going to see the value here. And it's important to understand is that in my list or in the set, we have integers, but you can have objects, you can have pretty much anything. And same thing here. You can have a key here, but the value could be pretty much anything, okay? Now, a couple of quick shortcuts, okay? So with a list, you don't need to actually print the 0 index, right? If I do my list, that's called a 0 index because my list is a list, it's an array. And this square brackets specifies the index that we want. So we don't need to do that, right? There's other ways. I can just do first. And that's going to be automatically first. So I can say print my list first. And I even have some documentation. If I hover over, if I select it, I have documentation. Returns the first element, okay? And that's because my list is actually an object, and an object has various methods, okay? And so this is like a built-in method from my list. So in this case, it's going to return 1, and I can also do last. Okay, and if we select that, it gives us documentation, returns the last element. So in this case, it's going to print 6. I'm going to run that, and now we see 6. Now, I personally do not know all the methods there are for lists, sets, maps, etc., etc. And it's not that important for you guys to know. Okay, it's not very, very important. It's just when you are building an app and you ask yourself, well, I want to print the first element. Is there a way of doing it? What you're going to do is you're going to go to the documentation for Dart. So what you're going to do is you're going to open this library docs here, this link, and you're going to open Dart core library here. And let's say you find the list right here. And here you see properties, first, last, length, reverse. You also have a bunch of methods. And you have all the information here in front of you because I personally, I don't memorize all the properties and all the methods that I need. I'm just building an app and if I don't know how to do something, I look it up. The most important thing is to have the language work for you instead of you memorizing everything. You don't need to memorize because you can just open a document and see exactly what you need to do. You just need to understand how to create a list, how to create a set, how you can create this map here. Now, there's another way of creating a map, and that is by forcing it to have a certain type, to be of a certain type. And you can simply do something like this, var my map, and then you give it the type. So we want a map where the keys are of string type and the values are of string type. And then you can start giving it different values. So you can do my map, you can say first, and this is some value here. And then you can print this value. You can do print my map first, like this, and that's going to print this value. So if I run this, I should see some value here. And we see some value there. And so there's another way of doing it. It really depends how you want to go about it. Doesn't really matter. Both ways are equally as good. Next, I want to talk about control flow statements. And what are those? Well, if you think about it, you're going to have an app that's going to be doing something, okay? We're not going to, define one variable, whether it's a list, set, or something else, an integer, string. and just print it out. You're going to have an app that's going to be executing something while a certain condition is true or until a certain condition is met, right? You're going to have something that's going to do it. And you typically do it using loops, right? A loop is essentially exactly what it says. It's basically a piece of code that iterates over and over again, meaning that it iterates the body of it until a certain condition is met. And there are three main loops that you see all over the place, not just in Dart, but in pretty much any programming language these days. And that is the for loop, the while loop, and the do while loop. So let's start from the beginning. Let's talk about the for loop. So a for loop looks something like this. We have for, and then you have your condition. So you have a starting condition. So let's say it's an integer, I is equal to 0, and I'm going to explain it in a second. And then you have a condition that guarantees this loop will continue until that condition is true, or while that condition is true. So I'm going to say until I is less than 10, and I'm going to increment this, okay? And so now we have a loop here. Okay, so we don't have any errors, we don't have any issues. So let me explain to you what this does. This loop is going to execute the code that's going to be written between these two curly braces right in here, and it's going to do it 10 times. Why 10 times? Well, we have a variable I, which is called like a control variable. It's inside this loop, and we set it to 0, and we say it, well, do it until it's less than 10, but increment it each time. So it's going to go from 0 to 9. Okay, 9 is the last time, because once it becomes 10, this loop, this is going to fail, and it's not gonna execute it. So 0 to 9 is 10 times. So I can do something like print hello world. And that's going to print it 10 times, because this loop guarantees that, whatever is inside of it is going to be printed from 0 to 9, while this I is less than 10, and I is being incremented once every time. So it's going to be 0, 1, 2, 3 until 9. So let's go ahead and run it. And we have it hopefully 10 times. Now, one thing that you can do is you can also include the I in there if you want. And the way you can do it is by doing something like this. That's called string interpolation. And you do it in situations where you don't want just to print like a string literal, meaning anything. You want to print a variable that contains something else. So we're not printing a random value. We're printing a variable that contains a value. So in this case, we're doing it inside the string. So that's going to display not just hello world, but also a number. So it's going to be 0, 1, 2 until 9. So let's go ahead and run it. Okay, so now you see that it executed it 10 times, 0 to 9. And on each execution, you are seeing the counter as well as the actual value that we have here. And obviously, you can take it as far as you want. You can do all that. But typically, when you are building these kind of loops, you're going to have an I. And if you're going to have another loop inside, you're going to call it a J. Okay, that's just standard convention. You can call this anything that you want. You can call this A, B, anything that you want. But standard convention, you're going to see it a lot in code. It's going to be an I. So I would just recommend sticking to that. Now, obviously, if you do something like, if you increment this by 2 instead of just by 1, you're going to have a lot less, right? You're going to have, five loops. 5 times that loop is going to get executed, because now each time you're adding 2 to the main loop. You're not just adding 1 anymore, okay? So you might have something like 0, 2, 4 until you get to the end result. So if you run this now, this should execute 5 times. So as you can see, 0, 2, 4, 6, 8, because now that, another one, the next one is 10, and 10 fails. It adds it, but because this is no longer less than 10, this doesn't get executed, okay? So, you can control it as much as you want, but typically this is how the loop is structured. I is 0 or I is something else, I is less than 10, I plus plus. Now, this is just one example of a loop. There are still 2 more loops that I want to talk to you guys about. The next loop is called a while loop, okay? And this is a simpler loop, also a loop that gets used all the time. And the only thing that you need to do when you're building this loop is that you need the keyword while. And I say keyword because this is a special word. You can't, you can have a variable called while. You can't have anything. it needs to be, this is going to be a loop. And inside this parentheses, you need a condition that needs to be true for this loop to execute. So once that condition becomes false, this loop stops. So let's say we have a variable called, we have int I0, and I say I is less than 10. This is the body of the loop, and inside the loop, I'm going to increment I. And so this loop is going to do exactly what the previous loop did. We're starting from 0. We are, waiting, and we're testing while it's less than 10, and we're incrementing it at the end of the loop. And so, the first iteration is going to be 0. 0 is less than 10. Okay, plus, plus. The next is going to be 1. Finally, when we get to 10, right, we did it. It was 9. We incremented it's 10. It's going to check it, and it's going to fail. So it's going to go from, 0 to 9 again. So let me run it. Print I, and we're just going to print our I, and we should get 0 to 9. And there you have it, 0 to 9. So it's pretty much identical to the previous loop, except it's a slightly different loop. And what's nice about these loops is that, well, you can do lots of different things with it, right? It doesn't need to be based on an integer that gets incremented. You can have something like, as an example, bool, is this, or I don't know, keep running. We can say true, okay? And then you can say while keep running, and that's automatic true. You don't need to do any of that, right? While keep running, and then you want to do something, and then maybe something happened. You can say print inside the loop, something like this. We need parentheses here. And then I can do something. I can basically set it. I can say, well, keep running is now false. Okay? And so what this means is that this is going to get executed just once. Okay? So it's true here, gets executed, and it's set to false. So it's going to print inside the loop just once. And here we see inside the loop. The last loop I want to show you is a do while loop. Okay? So the way this loop works is that we have a do, we have the body of the loop, and then you have a while. And then you have a condition. So maybe keep running. And the difference between do while and while is that do will execute at least once. While might not execute at all. And that is because while checks for the condition at the top of the loop, whereas do checks it at the bottom of the loop. So, this is going to execute regardless what keep running is. So if I say keep running is false, it's still going to execute, right? So I can do something like inside the loop. It's still going to execute at least once because it doesn't check anything at the top of the loop. Okay, so actually we need this. And so this is going to execute inside the loop. Then it's going to see keep running is false. It's not going to execute anymore. Check that out. And we have inside the loop. And so in my experience, the loops I use the most is the while loop. I use the for loop. I rarely use this loop. Although I see reasons to use it. I see its purpose. But that is not a loop that I use that often. I mainly use the while loop and the for loop. So depending on what you're doing, you have lots and lots of options. Now, before we continue, I want to quickly talk about the basic if and else conditions. Okay, you're going to be using this all the time, and this is an important construct to understand. So let's say we have an integer a, and that's set to 10. Okay, well, you need to test if something is something. So you might say if a is equal to 10, print a is 10. But you also need logic to happen if it's not 10, right? So if you want to test it against something else that's not 10, you can do else if a is less than 10. Okay, then you can have more logic. Print a is less than 10. Okay, but you can also have a catch-all condition. So meaning that if it's not 10, and if it's not less than 10, meaning that it's greater than 10, you can have a simple else condition here. And you can say something like print a is greater than 10. And so now, if we run it, it's going to hit this condition. And it's not going to go down any of these paths. So if you run it right now, hopefully it's going to say a is 10. A is 10. If I say, a is 15, it should say a is greater than 10. Okay, a is greater than 10. If I put a is 5, that should hopefully do a is less than 10. Okay. Now you don't need else if here. Okay. You don't need any of these. You need if, but these two are optional. So you can do, if else, you can do if else if, or you can do what I just did before, if else if else. A lot of times what would happen is you would have one if, and you would have multiple else if this, and then you can have else if that, and then your catch all else, meaning that, okay, we didn't catch any of those, do that. Okay, so you can have a condition. Now remember, if you have a Boolean, this is a bool value true, you don't need this equal sign. You don't need to test it. You can just put it in there. It's already a Boolean. It's testing it for true. If bool value is true, then this is going to get executed. Now, if you wanted to invert it, right, you can do something like this. And that's going to invert it, meaning that now it's not true. Now something else is going to happen. Now, obviously, in this example, I'm assigning a variable, but if your app is running, you have dynamic stuff going on. Maybe you're taking input from a user, you're getting some data from some website, or you're doing some calculation. The point is, the app doesn't know in advance, and that's going to be your typical situation. It's very rare you're going to set a value and then you're going to test it right here, right? And that's why this is complaining. It's complaining that this will never get executed because this is going to be always true because it's not being set anywhere else. So just so that you guys understand. Another important construct to understand is the switch statement, okay? And the way this works is that, let's say you have an integer, right? Int a is 10, okay? A really nice variable, a nice number there. So you can do something like switch a, and then you might have different cases for what that a can be. It's kind of like what I just talked about, that if, else, if, else, if, else, if, but it's a lot more elegant. And so the way this works is that you're going to put switch a, and then you're going to say case 1. You're going to say, print 1. Okay, and then you need to break out of it, right? You need to break it. Then you're going to say case 2, print, break. You're going to break out of it, right? Let's put a semicolon. Then you're going to say case 3, print 3, and you're going to break out of it, right? And then all the way at the end, you're going to say default. And default is if it doesn't match, meaning that it does not break, it doesn't enter any of this. Means that in this case, it's not 1, 2, or 3. You can just say A is not 1, 2, or 3. Okay, and you're going to do something like this, and then you can break as well. Okay, so now if we run it, we're going to be at this statement here. So check this out. Okay, so it's telling you A is not 1, 2, or 3. So this way is very nice, very elegant when you want to compare a certain variable to lots of possible values it can contain. Because else if gets old. I use it just if it has like 2 or 3 conditions, but let's say you have a lot of conditions, like 5, maybe even more. This is a lot more elegant. It's a lot easier to read when you're using the switch case, and then you're using this break. It's a lot easier to read as compared to if you are just, a lot of these else if, all these curly braces and stuff like that. So I definitely recommend using this if you have maybe more than 3 conditions you're checking. Otherwise, you can just do if, else, if. Next, let's talk about functions and their purpose. Now, the purpose of functions is to organize your code better, is to separate pieces of code depending on their responsibility, depending on what they do. So we have this one function here, this this special function, if you will, but I can define another function. Let's say we have a function that's gonna add 2 numbers together, okay? So in this case, a function has a return value, but it can also take in arguments, okay? Or it might not take arguments, and it might not return anything, okay? So in this case, we have a function that returns an integer, and it adds 2 numbers together. So it's going to be sum 2 numbers. That is what the function is called. And then it has 2 arguments, right? Int A, int B. Okay, so that is what the function looks like. And now we need to define the body. Okay, so we're just going to do return A plus B. Okay, and now everybody's happy. It accepts two numbers and returns one number, which is a sum. And then right in my main, my original function, I can define my numbers. I can say int a is 5, int b is 10. And now print sum two numbers, a and b. And what do you think it's going to print? Well, it's going to print the sum of these. It's going to print 15. So if I run this, I should see 15. And we see 15. Now, obviously, I could have, had a plus b inside our main. But what's nice about functions is that it allows you to, isolate a piece of code that you might be using multiple times, or at least isolate a piece of code that has a slightly different responsibility. So in this case, we can have another number. We can have int c, right? And let's say it's something like this. We haven't defined it yet. And then we can say, well, c equals, sum two numbers, a and b, okay? And now c is the sum. And in this case, c becomes the sum. So if I print it, I can just do print c. That's going to print the sum, okay? Now we're going to see 15 again, okay? And now we see 15 again. But I can, I can change the numbers, and I don't need to recopy. I don't need to copy and paste this function, over and over again. So let's say I have other numbers. I can say, well, a is now 11, b is now 13. I can do that later, obviously, and I can say, well, how about now? And I want you to print the new sum. So I can say, well, sum two numbers, a and b. And now it's going to print that sum. It's going to be 15, and then it's going to be 24. So I'm going to say 15. It's going to hopefully say 15, 24. 15, 24, right? And that way I don't need to copy and kind of, re-copy and paste the same code. It's a nice way to kind of separate. And you're going to see functions all the time, especially if they're more generic, right? You're going to have maybe a function that does one thing, and you need to reuse that functionality many times, several times inside of your app. That makes it a lot easier to kind of work with, instead of, constantly copying and pasting the code and constantly adding it up. And obviously, you're going to have functions that are more complex than this, right? This is just a beginner's introduction. You might have a function that accepts a list. You might have a function that accepts maybe a map, or, maybe a set or something else. But that is a very, very quick introduction to function. Another thing that's very important to understand are the classes. You're going to see classes all the time. And essentially what a class is, it's a complex type. A class can have other different types inside of it. And you can also create instances of classes called objects. So as an example, let's say we define a new class, car. This is how you define it. And you might have some kind of information about that class in order to kind of explain it, right? So a car can have like a model, a brand. So we're going to say string name, car name, string model, and then a string brand, okay? Now, as you might have noticed, if I do string name, string that, I am getting errors. And the reason I'm getting errors, I'm going to explain to you in just a second. But for now, what I need to do is I need to add a question mark. And I'm going to explain to you exactly what I just did in a second. And so I can add a method here. So let's say the method is going to be, print car, something like this. It's void. And this method is going to be attached to an object later on, as you're going to see. And it's going to print the car. So maybe we're going to say print name. Okay, and I'm going to say print, and I will say name. And what's that going to do is that going to print the name of the car. And I can also do void print model. Okay, and that's going to print the model. Okay. And then later on, somewhere in my app, I can actually instantiate this class and have an object with it. So I can do something like this, car, my car, car. Okay. And so now what that did is that created an object. Okay. So my car is now a complex object that looks something like this. And I can actually do, I can do car, my car, name, whatever, BMW. And then I can do something like my car print name. Okay, and that's going to print BMW. Okay, so if I run that, hopefully that's going to print BMW. Okay, now as you can see, BMW is over there. I can also assign a model, so I can say my car model, and I can say, well, this is 5 series. Okay, and then I can do my car print model. And that's going to print BMW followed by 5 series. Now, one important thing to make a notice of, if I type my car and I put a dot, it immediately gives me some suggestions, and that is a nice thing to have. Lots of tools do that, but as you can see, it's telling me brand, model, name in case I want to print one of these things here. But it also gives me some instance methods, some functions that I can run. Now, this is a function, but when it's inside the class and I'm using it on an object called my car, that's called an instance method, because this is a method now. It's a function, but a function inside the class is called a method, and this is an instance of this class. So the way you can think about is that class is like a blueprint, okay? By itself, it doesn't exist. I cannot use it, but I can create an instance of it. I can create a copy of it that I can actually use in the wild. Because this car right here is like a blueprint. It's instructions how to create these variables together. So in this case, I created one variable. I can also create another variable. I can create a second car, and now I can use that second car as well. And it's telling me I'm not using it, which I'm not, and probably I don't have any plans to use it right now, so I can remove that. Okay. Now inside the class, you can create something called a constructor, and that's a special function whose name is the same as the name of the class, and you can pass various parameters, and it's going to create an instance with these parameters filled in already. So as an example, let's say I want to do that, and I want to name this. I want to say string name string model. Okay, and that's going to be my constructor, and then I'm going to say, well, name, and then this model equals model. And now I'm getting an error here because you cannot create an object without any parameters. I have these parameters, so now I can say, well, I want a BMW, and the model is going to be 5 series. And now I don't need this anymore. Okay, it knows automatically what it is. So if you run it, it should say BMW 5 series. And there it says BMW 5 series. So that was a simple introduction to classes. For 90–80% of your work, you're going to be using them just like this. There's some other features that we're going to be covering a little bit later. Now, remember I just talked about how I needed to have a question mark to some of the values. And so let me quickly explain to you what that means. Let's say I create a variable called name. Well, by itself, if this variable is not assigned to anything, it's not doing anything, its value is undefined. By default in Dart, it's a null value, okay? And so with Dart, with a lot of latest versions of Dart, you need to make sure that if that variable might not be assigned at any point in time, because if you assign it right now, then it's not a problem, okay? But if you are not assigning it because you're not sure what that variable is going to have, you need to make sure that variable is nullable. And you do that by adding a question mark. And this tells Dart is that, well, I'm going to create a variable, but it's okay that it's null. It's okay that it's not assigned to anything. It's no problem at all. Don't worry about it. Now, in computer science, it's important to understand that it's very much preferred that variables are always assigned to something. You don't want like creating a variable like name and not assigning it, because the problem is later on when you try to read it, when you try to print it, when you try to access that variable, and if it's null, you're going to have a problem. There's going to be some kind of a crash, because typically null means that, it's not assigned to anything, and it may contain garbage. It may contain some really bad values that you don't want to mess around with. You don't want to read those values. And so the nice thing about Dart is that by default, these are not nullable types. So name here, it cannot be null. It needs to be assigned to something by default. So I can say James. But if I say, hey, don't worry about it, I'm going to assign it. at some point in time. But right now, I'm just going to say it's nullable, meaning that right now it's set to null. I can do if name equals null. I can do this check, and right now it's null. So it's going to say print, yes, it's null, right? So right now, if we execute this, its default is null. Okay, so if we do that, it's going to say, yes, it's null, because it's not assigned to anything, right? Yes, it's null. But if I assign it here and say name is James, this is not going to execute anymore, okay? And it's even going to complain. It says the operand can't be null because it knows that it's already assigned, so it's not null, okay? But the reason it's complaining because it knows it right away. But when you're running the app, it's all going to be dynamic. And so this compiler, it's not going to know beforehand, okay? Because it's running it, you're getting data, you're processing data, you're doing all kinds of things. And so it's always a good idea to always make sure that your variables are assigned to something. And that is why, you're typically not going to have question marks. Typically, you're going to say name, and then you're going to say, well, it's assigned to James, okay? And that way it's not null. It's only going to be null if you force it to be null, but because this is not a nullable type, meaning you don't have this question mark, it's not going to allow you to do it, right? So if I do something like this, name is null, it's not going to allow me to do that, okay? Because it's telling me that this is not a nullable type, but if I do that, it's going to allow me to do it, okay? Now it's a nullable type. So this is something very, very important to understand. This is a great feature in Dart. It's actually a relatively new feature, right? It wasn't initially introduced with, when Dart was introduced, it was introduced a little bit later. And a lot of old languages like, relatively old, like C, C++, it's very, very common to set something to null or set something to some bad variable, and then your program will crash. And here, Dart is going to catch it, right? If you say, this is not a nullable type, and you set it to null, it's going to let you know. It's not going to compile the app. And so the workaround, well, it's not a workaround, it's kind of a feature, is to have a question mark, and that way you're telling Dart, hey, don't worry about it. It might be null, it might not be assigned, but I'm going to assign it to something, I promise. Otherwise, it's gonna crash the app. So there you have it. Very, very important to understand. This is called null safety in Dart. And so that is a quick introduction to the Dart programming language. I really hope you've gotten value here. If you did, definitely subscribe to this channel, like the video, leave a comment below. We're going to have lots and lots of great content on Dart, Flutter, and other interesting computer science concepts. Thanks a lot for watching, and I'll talk to you real soon.